children, this is Hanuman sir here. In the previous class we are discussing about playing with numbers, different types of numbers, letters and digits, so generalized form of numbers and divisibility rules, right? Yes, so next we have second chapter, that is rational numbers. So rational numbers, so the rational numbers, the numbers which can be represented in the form of p by q, where p and q are integers and q is not equals to 0, is called a rational number, right? So the number which can be represented in the form of p by q, where p and q are integers and q is not equals to 0, is called a rational number. So for example, 2 by 5, 7 by 8, 5, 0, 1000, 1 by 1000, etc. right? So p by q, so here the numerator is 2 and the denominator is 5, so p equals 2 and q equals 5, p equals 7 and q equals 5, 8, p equals 5 and q equals 1. So there is a 1 here, so where q is not equals to 0. Yes, 0 is a rational number, so 0 by 1, so 0 by anything is 0, so under 0 there is a 1, so that so 0 is a rational number, so because it is in the form of p by q, where q is not equals to 0. And 1000, so it is also a form of p by q, so that p by q, so 1000 by 1, where q is not equals to 0, here q is equals to 1, so 1 by 1000 and so on, right? So the rational numbers, so the numbers which can be represented in the form of p by q, where p and q are integers and q is not equals to 0, is called a rational number, right? So examples, 2 by 5, 7 by 8, 5, 0, 1000, 1 by 1000, etc. right? So rational numbers can be represented as a capital Q. Rational numbers can be represented as capital Q or capital J or small r. So rational numbers can be represented as capital Q or capital J or small r, right? Yes, so all natural numbers are not all natural numbers are rational numbers, but the converse may not be true. So all natural numbers are rational numbers, but all rational numbers may not a rational number, right? So all the rational numbers are rational numbers, and all rational numbers need not be a natural number, right? And also all the whole numbers are rational numbers, but all the rational numbers need not be a whole number. And all integers are rational numbers, but all rational numbers need not be a integers. And all fractions are rational numbers, but so all rational numbers need not be a fraction, but the converse may not be a true, right? So all the natural numbers, whole numbers, integers and fractions are rational numbers, but the converse may not be true. For example, minus 3 by 4, here the numerator contains minus 3 and the denominator is minus 4, right? Yes, so for example, minus 3 by 4 is a rational number which is in the form of p by q, where p is minus 3 and q is 4, right? So but it is neither a fraction nor an integer, also it is neither a whole number nor a rational number, natural number, right? For example, minus 3 by 4 is a rational number, but it is neither a fraction nor an integer, also it is neither a whole number nor a natural number, right? Yes, so rational numbers which can be expressed in the form of p by q, where p and q are integers and q is not equals to 0, is called a rational number. Okay, next we have properties of rational numbers. So the first property is closure property. So we know that two whole numbers, so the natural numbers along with 0 is known as whole numbers. So the whole numbers can be represented as capital W, and so the least whole number is 0, right? So let us revisit the closure property for all the operations on whole numbers in brief. So operation, numbers and remarks. So addition, right? Addition. So 0 plus 5 is equals to 5. So we know that 0 is the additive identity element and 1 is the multiplicative identity element. So under whole numbers, so addition, so 0 plus 5 is equals to 5 is a whole number, right? So 4 plus 7 is equals to a dash. So is it a whole number? Yes. So 4 plus 7 is 11 is also a whole number. In general, a plus b is a whole number for any two whole numbers numbers A and B. So all whole numbers are closed under addition. All whole numbers are closed under addition. So it follows the closure property of addition. Whole numbers are follows the closure property of addition, right? So next we have subtraction. So subtraction, so that is 4 by, yes, so 5 minus 7 is equals to 2, minus 2. So here the greatest sign is minus 2. So 5 minus 7 is equals to minus 2, which is not a whole number, which is not a whole number. So whole numbers are not closed under subtraction, right? So because it contains a negative natural number, so we know that, so the whole numbers contains natural numbers along with 0, so that so minus 2, which is not a whole number, so whole numbers are not closed under subtraction. So next we have multiplication. So 0 into 3 is 0. So we know that 0 into anything is 0, a whole number, right? Yes, so 0 into 3 is equals to 0. It is a whole number. So 3 into 7, 3 sevens a dash. Is it a whole number? Yes. So 3 sevens are, we know that 3 sevens are 21. So it is a whole number. In general, A and B, if A and B are any two whole numbers, their product AB is a whole number. So whole numbers are closed under multiplication. Whole numbers are closed under multiplication. Yes. Yes. So next we have division of whole numbers. So division of whole numbers. So 5 divides by 8. So 5 divided by 8. In general we take 5 is the new divisor and 8 is the dividend. So 5 by 8. Here numerator is 5 and denominator is 8. So 5 divides 8. So 8 is the divisor, 5 is the dividend, which is not a whole number, right? So because we know that, so the whole numbers are 0 along with the natural numbers. So 5 by 8 is not a whole number, such that whole numbers are not closed under division. So whole numbers are very close to, and it obeys. So whole numbers are obeys closed under addition, and whole numbers are closed under multiplication. But whole numbers are not closed under subtraction, and whole numbers are not closed under division. Is it clear to all children? Yes.